All right, good afternoon, everyone. Dr. Jensen here. I'll do a quick video here to talk about the scientific method. Now, scientific method is usually taught in every science class. In every science class that we take, we always start off with what is the scientific method? It is the basis for how we understand things. So, a couple of things that we generally look for or want to be able to understand for sure is to be able to describe the various parts of the scientific method, to be able to distinguish between the definitions of hypothesis, theory, and law. And sometimes we will use this in an application of by looking at how do we identify these various processes within various kinds of literature. Right? Scientific method, we have for a long time tried to understand the world around us, the universe around us. And so I'm trying to come up with how do we best derive information. And once we start with observations of there are things around us, how we best validate our understanding is through experimentation. And so the scientific method that we're going to talk about here is really, in most cases, considered by many people one of the single greatest concepts in human history. How do we best to identify something that is true? How do we validate our knowledge? And so the scientific method is a process. That is the most important thing to always remember here, that a process of observation, data collection, and analysis. It is not, it is never complete. Our knowledge is never complete. We do not ever stop learning. We do not ever stop exploring. When we look at the basics of the scientific method, what you're going to see here are these circles or these arrows that revolve around. It is an iterative process. It is meant to be searched and researched. That is why it is called research, because we are searching and researching for answers. The flow here of hypothesis through experiment to theory and law is, as we go through these, as we start with a hypothesis or observation, observations are generally where we will start, or an initial guess. And yes, it is perfectly scientific to make a guess. We want to put a guess down as to what do we think is happening with a particular phenomenon. A hypothesis is our verbalized idea that we are going to be able to test. Now, a good hypothesis is one in which we can test. Okay, a bad hypothesis can be vague. Okay, if it is too vague and we cannot create a hypothesis, and we cannot create an experiment, then it is difficult to generate information. Okay? It is difficult to validate a hypothesis through experimentation if our hypothesis is too vague. Okay, or it is too difficult to create an experiment to validate what we think is going on. Okay, so in most cases, real science is generally very complicated. A simple hypothesis is usually not something we can really drive to. A lot of times when we're initially doing science, when we're learning science in the undergraduate arena, usually a hypothesis, the fundamental question of our research is easier to derive, right? As we get into larger kinds of research or various kinds of medical research, the hypotheses generally tend to become a little bit more complex in the variables that we work with, right? But we create an experiment that tells us whether or not our hypothesis was right or wrong, okay? We want to know, was I wrong? Okay, if I can't find an experiment that demonstrates I'm wrong, then for the time being, the initial hypothesis stands as correct. A theory is what we generate, is the body of knowledge that we generate. Okay, by asking questions and performing experiments, we generate a body of knowledge about a phenomenon. Okay, theories do not become laws. Okay, there is no arrow here that goes down to a law. Okay, common misconception in the scientific method is that theories become laws. That is not how this works. Okay, a scientific law is something that summarizes observations and experiments, usually in a simple statement, usually in a mathematical expression. Okay, think of the law of gravity. Okay, the law of gravity, and there is also gravitational theory. Gravity is both. Okay, the theory explains various components of the phenomenon. The law simply is a mathematical expression about the attraction of objects to one another. But it's not explanatory. It doesn't explain what happens with the phenomenon. What happens when light passes a high gravity object? Okay, the law doesn't explain that. It doesn't explain what happens. It describes a general phenomenon. Okay, so the hypothesis where we're starting should be one that can be tested. If it can't be tested, it is not science. Okay, we generate a variety of kinds of experiments. Kinds of experiments that we may do depends on the kind of research that you want to do, how complex your hypothesis is. There are all kinds of variables that we often have to control for. Okay. Scientific law, as I said, is the summary of observations into a general statement. In chemistry, we work with a variety of laws. Things like Avogadro's law, Boyle's law, Charles' law, Hess's law. These are generally the kinds of laws. They are mathematical equations that just, that tell us what happens when we work with a phenomenon. Boyle's law looks at the relationship of pressure and volume of gases. Okay, it is a mathematical expression. Okay. Many scientists, oftentimes we have to constantly harp on the difference between the colloquial version of a theory and a scientific theory. Words used in context have different meaning. Okay. Socialism and democratic socialism are not the same thing. They do not have the same meaning. Yes, they both have socialism in them, but they do not have the same meaning. Theory and scientific theory both have the word theory in them, but they do not have the same meaning. Okay? Things take on different meanings when we use them in certain contexts. Okay? So a theory is a well-substantiated explanation of some aspect of the natural world. It is based on facts that have been confirmed through observation and experimentation. Okay, a theory is everything we know about a subject. Theories are considered the pinnacle of scientific knowledge. Okay, a theory is not a simple guess. These are lots of experiments go into developing the body of knowledge for a theory. Okay, we cannot invalidate a theory by a bad experiment. Okay, I use the example, the dictionary has a lot of words. It has everything we know about the words of, say, the English language. A misspelled word does not invalidate the entirety of the English language. Okay. Or as we add and make new slang words, it does not invalidate our understanding of words. Okay. So theories do not become laws. It is not linear. Gaps in our understanding do not invalidate our understanding of things. Okay. That is why we continue. That is why the process of the scientific method continues. It is always meant to drill down and further understand what we don't know. Okay. Our learning never stops. Our experimentations never stop. Okay. We build a body of knowledge about our reality. Okay. Oftentimes when people talk about things of, well, it's just a theory, they're usually talking about evolution, and they're usually talking about it because it conflicts with a religious ideology that they hold. Generally, they don't talk about germ theory as just a theory. We don't believe really that demons cause you to have Ebola, right? We don't get a cold from witches, right? So theories are bodies of knowledge. So germ theory is everything we know about germs. Just because there is a new germ does not invalidate the body of germ theory. Okay. In chemistry, we study atomic theory. We also study things like Lewis theory and molecular theory. These are refinements of our body of knowledge of atoms. Okay. A way that I usually describe the scientific method is like this. When we look at the moon, okay, we observe that we have a moon. Okay. Many cultures have identified that there was an object there. Okay, so we create a hypothesis. How did we get the moon? Okay, did it spin off of the Earth when the Earth was, more liquid and hot? Is it kind of this ball of molten magma that it was spinning so fast that a little globule fell off? Was the Earth, as the Earth is there, did something come by and just get stuck in our orbit and we captured it? Got caught in our gravity? Or did something hit us that a spray of stuff came off and it's eventually coalesced into the moon? Okay, so we have to create experiments. We had to go to the moon and collect samples. So the experiment that was derived was we could test the mineral content of the moon and compare it to the mineral content of the Earth. Okay, in the Earth's core or crust. Okay, if these two things are the same, then we would say that by and large, if it was identical enough, it could be said that maybe just the Earth was spinning so fast that some piece of it came out. Like if I have a cup of water and I'm spinning my water, droplets of water are going to come out. The water outside the cup is the same as the water inside the cup. Okay, or it would be totally alien. We analyze mineral content of meteorites, and we see that they are totally different than the mineral content of the Earth. Or there's going to be some mixture. And so what we find is that the mineral content is not quite the same. It's not identical, but it's also not wholly alien either. So it indicates that there must have been some sort of giant impact that collided some other object with the Earth. And then we begin to develop models to come up with how might we have gotten that kind of content? What would give us this particular mineral content? Okay, how big would it have had to be? Right? What angle might it have had to impact us with, right? Because obviously our Earth is made up of different layers, and so the layers have different compositions. And so if it hit really deep, that might have changed the mineral content versus a glancing blow. Okay, but we develop this body of knowledge by running experiments, by looking at the moon in different ways. And we can develop an idea of what is its, how did it happen? Okay. But all of our experimentation builds to our body of knowledge that we have about them. And that is how the scientific method works. We just apply it to various areas. And so that's going to be it for our scientific method. And come back with another short video, and we'll start working on some other segments of our initial first chapter. But every class deals with the scientific method. If you take a science class and they don't start with the scientific method, you might not be in a science class. All right, that's it for today.